Chapter 5, Section 1 is talking about nth roots of rational exponents. Okay, essentially what we're doing is instead of always working with a square root, like you guys are used to, okay, mostly we've worked with square roots, we've done a little bit with cube roots, right? Okay, we are going to start putting different numbers here. Now, this is just understood, okay, it's not actually written, that that's a 2, square root. Okay, Austin, sit up. Okay, so you could write a 2 there. We just understand that it's just there. Okay, it's like writing a 1 in front of x. We don't have to. We just know it's 1x. Does that make sense? Okay, so starting today, we're going to start doing things like this or this. Okay, we're going to add different numbers, and there's no limit as to how high that number can be. Okay, our standard form of this is the nth root of A. Okay, so we will be working with different nth roots of numbers. Okay. If, and when we get to something tomorrow, we'll get to it tomorrow, we're not going to get to the whole thing today. But if I have an even radical, this is going to have to be plus or minus. Okay, kind of like what we did with our square roots. Okay, because let's just do one here. Let's do 32. The fourth root of 32, 16. Fourth root of 16 is what I'm looking for, is plus or minus 2. Okay, because I can either take 2 times 2 times 2 times 2 and get 16, or I could take negative 2 times negative 2 times negative 2 times negative 2 and get positive 16, and get positive 16 as well.
That's only plus or minus with evens.
With evens, because if I have the cube root of 27, first of all, what times itself 3 times is 27? 3. If I do negative 3 times negative 3 times negative 3, what's that equal? Negative 27. Okay, so is this possible to have? Yes, this would be negative 3. Okay, yes, Peyton.
So is it the exponent or the actual number is odd or even?
N. If n is even and you're solving an equation, you're going to need plus or minus. Okay. Now, taking a look here at example 1, okay, they tell me that n equals, let me do a different one than what you have. Oh, let's just do this one actually. N equals 4, A equals 81. Okay, well with this information here, you should be able to set this up and plug in, right? If they're telling me to find the nth root of A. So it would be the fourth root of 81. So what you're asking yourself is what times itself 4 times is equal to 81? It's 3. And if you're solving an equation, it would be positive or negative 3. Okay. Now, there's some of these that you're just going to have to think about. There's others that I would kind of expect you to know. Okay. You should know all your perfect squares. Okay, all your easy ones, especially up to like 144, right? Maybe even 169. Okay, or excuse me, 196. Okay. There's some cube roots that you should know also. Okay? You should know that 8 is a perfect cube of 2. You should know that 27 is a perfect cube of 3. You should know that 64 is a perfect cube of 4. You should know that right? Yeah. You should know that 125 is a perfect cube of 5. Okay? Past that might not be necessary, okay, but those other ones that I just talked about, you're going to use a lot. Okay, so you should know those. What I don't want you to do, and I do know that your explorations and communicate your answer and your maintaining mathematical proficiency yesterday had you do some calculator work, right? Okay. You need to know how to do this stuff without a calculator in most cases. If it doesn't tell you to use a calculator, you should try not to use a calculator. And I promise you, if you're the student that doesn't believe me on that, when we get to doing things with variables, and I'll show you an example here after a little bit, you're going to have no idea what's going on. Okay? I'm telling you that because I've had those students. Okay? I've had the students that are like, oh, I'm just not going to listen to him. I'm just going to plug it in my calculator because it's easier. And then we get to variables and they have literally no idea what we're doing. Okay? They're setting you up for more difficult things. There's a reason they're not telling you to use a calculator on all of them. Okay? And the ones I'm talking about are like example 2. So looking here at our core concept with rational exponents, we are looking at things like this. Okay, and you saw these yesterday. For example, you had like 7, let's just use 4, to the 1/2 power. Okay, you started getting exponents like that, correct? Okay, you should have seen some of those. Okay, this a to the 1 over n is equal to the nth root of a. So an exponent as a fraction is another way to write a radical. Okay, so this would be the same as what? N goes out front. What? It'd be the second root of 4. Well, what's the square root of 4? 2. Okay, you might have a 1/3. Okay, maybe I have 12 to the 1/3. This would be the cubed root of 12. Okay. It's just a new process for you. Okay, and a fraction exponent is just a radical written in a different form. Okay. Now what they're talking about down below, they make it a little bit more difficult. They use a to the m over n. What is the only difference in what I have here in black and what I have here in red? Instead of a 1, it's an m. Basically meaning instead of a 1, I could have like a 3 or a 7 or some other number, right? Okay. If your top number is not a 1, you can change it into a 1 by putting it outside as an exponent. Okay, you did some of these yesterday too. An example of one you might have done yesterday, you had like x to the 3rd to the 5th. Right? What did you do with those two exponents since it was what we call a power of a power? You multiplied them here. Okay, you took 3 times 5. If I took m times 1 over n, I would end up back at the beginning, right? Okay, so I'm going backwards with this. Okay, we'll get some examples here after we go. Now what I'm looking at here is this exact same thing, correct? Okay, I just turned it into this. So I can write this as the nth root of a to what power? To the m power. Okay, so let's do it. Yes. Okay, what we're doing is we're simplifying in different ways. Okay? And again, this is all setting you up for in a couple sections when we're doing this with variables. Okay, they're just setting you up right now. You do need to know how to do this, obviously, but they're setting you up for something we're going to do down the road. Okay, now, so let's just do an example here. Let's say I have 26, which is not going to be a perfect cube or anything, to the 4/3 power. Okay, all I want to do is I want to change it into radical form. So I want to change it from a rational exponent into a radical. What's my first step? make that 4 into a 1. So I have 26 to the 1/3 to the 4th power. Okay? And now I can take that 1/3 exponent and turn it into a cubed root. So I would have then the cubed root of 26 to the 4th power. And I have changed that from a rational exponent into a radical. Yeah, and you would simplify it if possible. 26 is not reducible, though. Okay, so an example of your question, they're going to say, evaluate each expression. Okay, meaning you should be able, if they tell you to evaluate, you're going to get an actual number answer. Okay, we'll do one here in a second. Okay, now, you're going to start seeing a pattern, and you're going to start being able to skip this front step. That's going to happen. That's fine. Feel free to do it once you catch it. Okay, so let's say I have 32 to the 9/5 power. If you skip a couple steps, you're going to know the bottom or the denominator is going to be your radical. The numerator is going to be your exponent. So I have the 5th root of 32 to the 9th power. Okay, if you can skip that middle step, feel free to do it. Okay, all they're doing here is showing you the base, showing you the foundation of why this works and how all the steps are working. Okay. Questions so far on that part? Okay, we'll do some more examples here in a second. Okay, the next thing in that core concept is if you have a negative exponent. Now, we did talk about this a little bit yesterday. What happens if you have a negative exponent that you need to do? You need to change the sign somehow, which yesterday we did it by doing what? Putting it in the denominator, right? Okay. So the first step that they do on your core concept is they make your exponent positive, and that should be your first step every single time. If you see a negative exponent, make it positive. Get rid of that negative. So I'm going to change this to 1 over a to the m over n. Now notice here, this denominator is this exact same thing, correct? So I should be able to reduce this down and end up with the exact same thing as here, but it will be where? It'll be in the denominator. So I should end up with 1 over the nth root of a to the m power. Okay. Now, just a general rule for us. If you have a negative exponent and you need to make it positive, all you need to do is transfer it over this fraction line. Okay, the saying I was taught is cross the line, change the sign. Okay, meaning, if I have x to the negative third and it says write this with only positive exponents, it's over 1, right? Cross the line, bring it to the bottom. Now it's positive. Okay? Based on my saying, does it work also if your exponent is negative in the denominator? Yes. Cross the line, change the sign. X to the 5th over 1 is the exact same thing. These are equal to each other. Okay, so if you have a negative exponent, all you need to do is change whether it's in the numerator or denominator to make that thing positive. Okay. So, let's do one example from example 2 here. They give me 16 to the negative 5/4. What should be your very first step? get rid of the negative, right? Make that exponent positive. Okay? How do I do that? 1/16 to the 5/4. And some of you may have been able to do some other steps first, or while you did that. Okay? So by changing this into radical form, okay, because they did not tell me to use a calculator here, and I have no idea what 16 to the 5/4 power is, right? So I'm going to change this into radicals. So I can change this into 1/4 root of 16 to the 5th power. Okay, what is the 4th root of 16? It's 2. 2 to the 5th power is? It's 32. So I have 1/32 as my answer. Okay, those right there are the types of problems that people get too lazy on, and they just want to type it in their calculator. And then when we get to our variables, and I was trying to see what section that's in. I'm not 100% sure what section it's in. Okay? But when we get there, they have no idea what to do. If it does not say use a calculator, try to do it without a calculator. Okay, there's a reason they're telling you not to use one. Okay, I promise you it will set you up better as we get down the road. Oh, there's some problems just in the next section. There they are. Okay, so next section. If you can't do this stuff without a calculator, you're going to struggle next section. Okay, now I do want to take a look at example 3. What's the difference in what the directions in example 3 say? Evaluate each expression using a calculator. Now can you use a calculator? Yes. Okay, and the reason they're going to have you doing that now is because you're going to get weird decimals that are not fractions. Okay? You're going to get irrational answers. You can't write it as a fraction. Okay? So, what I have here, let's actually everybody go grab a calculator if you don't have one. So I can make sure you know how to type these in. Gage, you got a calculator or are you just taking a nap? Okay. Okay, so the first one, and this one shouldn't be too difficult. 9 to the 1/5 power. Now you might have to be careful. When I type this in, I would type it in as 9 caret parenthesis 1 divided by 5, close my parenthesis. Okay, if you don't use your parentheses, it's going to take it 9 to the 1st power, and then it's going to divide it by 5.
You don't got to do the whole 5 roots.
You do not have to. You could, though. Okay?
Do 1.5518.
You should get 1.55 approximately.
Okay.
Okay? Did everybody get 1.55? Okay. The next one, same type of thing, 12 to the 3/8. I would type this in the same way, it's just instead of a 1, it's a 3 now. You should get about 2.54. Okay, let me know if you don't get it and I can see what you're doing wrong. Okay. Now the last one, they have the 4th root of 7 to the 3rd power. Okay, now, there's a couple things you can do here, guys. One, You could use this button. Instead of a square root, it's an X root. Okay, if you are going to use that button, it's second caret. If you are going to use that button, you need to write or type in this number first. So on your calculator, it should look like this. 4 X root, and then it should put a parenthesis, I believe, and a 7. And then I would close that. And then what I would do from there is I would hit enter, and then I'd take it to the third power. What's that? Not times 3, to the third power.
Okay, I got it. Wait, you gotta press 4 before you...
Yes, you have to do 4
Second.
X root or second caret, and that'll pop this up, and then 7. Okay, what that's going to allow you to do is I could ask you to give me the 97th root of 4 million, and you could go 97 X root 4 million, enter. Okay, now, that's one way to do it, is to use the X root. Another way to do it, if you understand what this means 7 to the 3/4 power. Thank you. Right? Based on what we talked about a little bit ago, that's 7 to the 3/4 power. Hey, which I assume must be how you got it so fast, Damien, right? Hey, they're the exact same thing. It does not matter how you type it in. You should get the exact same answer. Okay? Again, don't use your calculator on the ones they don't tell you to use it on. I promise you that it will hurt you. Okay, I expect your class to believe me, because you usually do. Okay, but there are some students that I think are going to try to call my bluff, and they will regret it. Okay, somebody's going to do it. I don't know who it's going to be. Somebody will do it, and we will get to the next information, and you will have no idea what to do. I promise you, somebody will do it. Whether it's in this class or fourth period, somebody's going to do it. See if I want to call them out or not. Okay, so what I want you to do, I gave you quite a few of these because how important the process is. Okay, I need you to solve through problem number 32 on your homework assignment right now. 32.